All right, lesson 2-7, parent functions and transformations. So by the end of this section, we should be able to describe transformations, graph transformations, identify the family of functions, and find domain and range. So to start with, a family of graphs, or a family of functions, is a group of graphs with similar characteristics. So this means that the graphs are going to look very similar to each other. And then within a family of graphs, our parent function is the simplest of the graphs in that family. Okay? So we're just going to start with our family, each family of functions that we're going to talk about and what their graphs look like. And then we're going to list their parent function and their general equation. Okay? So the first one that we're going to talk about is going to be a constant. So remember, a constant just means a number. Okay. So I'm going to see kind of f of x equal to any number. So I'm just going to choose a. So a stands for any number. So when we graph it, it's going to be some type of horizontal line. So it's going to look something like this. And this line comes from wherever this number is. So if I kind of give this a specific graph, so let's say it's at this is at 2, so my equation would be f of x equals 2. Or if we wanted to graph g of x equals -1, I would go down to -1. I'm going to draw a horizontal line through it. So all constants are going to have a horizontal line as their graph. And there really is no parent function or general equation for this one. It's just this equation for constants because the constant really is the most basic graph that we can ever draw. Okay. Our next one, so it's our linear equation, and our general one we know as the y equals mx plus b. And then our parent function, so the very basic graph is just x, so y equals x. So it's going to be a straight line. It's going to have a diagonal to it. So it's going to look something like this. The next family are the absolute value family. So our general equation is going to be a times the absolute value of x minus h plus k. And then our parent function, so I'm using p of x for parent function, is just the absolute value of x. So that is our most basic function for this family. And all of these graphs are going to be some type of V shape. So it's going to look something like this. Or it could open upside down, but it's just going to be some type of V shape. All right, and the last family that we're going to talk about are quadratics. So again, our general equation is going to be a times a quantity of x minus h squared plus k. And then our parent function is going to be just x squared. So this family is going to be a U shape. So it's going to look something like this. So again, it can open up, or if we want it, it will also be able to open down. Okay, but a quadratic equation is a U shape. Absolute value is a V, linear is a diagonal line, constant is a horizontal line. So those are the 4 families that we're going to be talking about. Now, each of these families, based on its general equation, we can change from our parent function. So those changes we're going to call transformations. So transformation is, again, how a parent graph changes between its parent graph and its general equation. Okay? So there are 4 different types of transformations. So our first one is horizontal translation. So this is when our graph moves to the left or to the right. We have a vertical translation, so that's going to be when our graph moves up or down. A reflection flips our figure over our line of reflection. So really this is going to determine if it opens up, or if there's a reflection, it's going to open down, or if it's a linear equation, it's going to slope in the opposite direction. So it's going to angle down. And then our last type of transformation is called a dilation. So it's a shrink and So it's either going to shrink or enlarge a figure proportionally. And for these words, we're actually going to be using compress or stretch.